Hello students, myself Rahul Kotkar, and here we have to study the mechanical properties of fluid. It's our lecture number 7. In the previous lectures, we studied about the shape of meniscus, in which we studied the formation of concave meniscus and convex meniscus. Now in this lecture, we are going to study about zero angle of contact, which is also the topic covered under the shape of meniscus, which is a number 3rd, that is zero angle of contact. So for which we consider here the liquid is taken inside the solid, in which we can say here A be the liquid molecule situated and in contact with solid. Okay, means what is that? The liquid molecule is poured in liquid poured in a solid, okay, and in which we observe there. Let me consider the sphere of influence around the molecule A. Okay, everyone know about the sphere of influence. Okay, that is the imaginary sphere drawn with a center. Molecule is at its center and radius is equals to the range of molecular force. Then we consider AP be the net adhesive force between solid and liquid. Okay, so it can be shown here. Adhesive force means force of attraction between solid and liquid. And let here you can see carefully what you observe. You observe that AP be the force directed inside the solid, which is shown here by arrow. Then next is your AC be the net cohesive force between the liquid and liquid molecules. Okay, the cohesive force means what? The force of attraction between the similar molecule, and here similar molecules are molecule A is of the liquid as well as the liquid taken is of a same liquid. Okay, then what we can say here, the liquid molecules near the contact region are less in number. Okay, means the point where the liquid and solid are in a contact. Okay, region or the particular point, okay, where we seen that the number of liquid molecules in a contact with the solid are very less, means approximately equals to 0. So because of that, we say here, if there is very less molecule or no molecules of liquid are there, so there is no cohesive force. Means cohesive force due to the liquid molecule is equals to 0. Okay. Then AR be the net resultant force on molecule A. Means due to the adhesive force and cohesive force, the net force acting on molecule A is given by AR. Okay, but here as you observe in this case, AC having 0 value means force due to the cohesive molecules is 0. Cohesive force is 0. So what about the adhesive force having certain value? And so the resultant force or net force on molecule A is lies along the same direction as that of the AP, and that's why I written here AP is equals to AR, which is shown the diagram. You can observe there. Okay, what is that? AP and AR lies along the same direction. Okay, next is your AT. So what about the AT? AT be the tangent drawn to the liquid surface, and this tangent drawn to the liquid surface is always perpendicular or normal to resultant force AR. So which you like observe in the figure. Okay, that is AT, which shows the tangent or normal to the resultant force AR. Then what about the theta? Theta be the angle between solid surface and tangent drawn AT. What is the theta? angle in between, everyone know theta be the angle of contact, and it is defined as, that is the angle in between tangent drawn to the free surface of liquid and a solid surface at a point of contact, which is measured from inside the liquid. So here the liquid level lies in such a way that, okay, the tangent should be which is parallel to the surface of solid, and so what we can say, the angle in between tangent drawn and the liquid surface, solid surface is equals to 0. And now in this manner we can say here, the adhesive force acting on a molecule A should be very, very greater as compared to the cohesive force acting on liquid molecule. Okay, why this so? Because there is no presence of liquid molecules around the molecule A, and that's why what happens, the adhesive force should be the very stronger. And as adhesive force is very, very greater as compared to the cohesive force, then what we can say, the liquid completely weights a solid. Due to that, there is a liquid which completely weights the solid and forms plane meniscus. Okay, at actual, as you observe this diagram, means in which what we can say, the liquid completely weights the solid surface. If suppose we consider this is the solid surface, then this liquid will be completely, okay, weights the solid surface. Okay, actually somewhat gap is there because of the writing issue. Okay, but as you observe in case of concave meniscus, you observe there is the formation of meniscus like this. In case of convex meniscus, you will observe it should be the like this. Means these shapes can be formed in that case, but as in this case you have found there, I will show you what you observe, it's the somewhat straight. Okay, and that's why the much more liquid will be in the contact, and so the step will be given here, the completely weights a solid, means liquid completely weights a solid and forms the plane meniscus. And the example of this can be given by a simple, that is a pure water in clean glass, means the glass plate or the glass used should be the clean as well as water should be the pure. Then and then you can observe there is the formation of zero angle of contact. Okay, remember here zero angle of contact. Okay, then there should be the formation of plane meniscus in which the liquid completely weights a solid, and the example can be given pure water in a clean glass. Okay, and formation of meniscus as a plane meniscus. Okay, so remember these points, and this figure is shown in the your book. Okay, so go through this topic. If you have any doubt related to this, can ask in the comment section. Okay, next point that we have to start, that is angle of contact 90 degree and conditions for convexity and concavity. Okay, so friends understood what I am saying. Here we have to form the angle of contact as a 90 degree. Means what? The angle of contact should be the 90 degree. In this case, what we have to achieve? The angle in between the tangent drawn to the liquid surface and the solid surface should be equals to 90 degree. Simple. Okay, and for achieving that, what we have to consider? So look the figure. Here we consider the hypothetical liquid, okay, having angle of contact 90 degree with a given solid container. Okay, the means liquid consider here, which is a hypothetical, imaginary, and having angle of contact 90 degree. Okay, means having a theta as a 90 degree. So here the figure shows you the solid and liquid in a contact. Now we consider here A be the molecule of liquid which is situated inside the liquid but in contact with solid. And here we consider the sphere of influence around it. Okay, the sphere of influence is nothing but what? The imaginary sphere drawn with a molecule A is at its center and radius is equals to the range of molecular force. Okay, then we consider that as similar to the previous one again, AP be the net adhesive force. It is the adhesive force between the different molecules, say as to solid and liquid, which shown here by this arrow or vector AP. Okay, what about the next? That is AC. AC be the net cohesive force between the liquid and liquid molecule. Okay, means force of attraction between the two similar molecules. That is a cohesive force, and here which can be represented by here AC as shown in figure. So you can observe AC be the net cohesive force. Now here in this case we consider that, or we observe here, the AC exactly lies at 45 degree with either of the surface. Okay, means what I have to say, in this case, as you observe here, okay, observe the diagram carefully, in which you observe that the AC should be present at exactly 45 degree either of the surfaces. Means what? This maybe makes 45 degree with this solid surface or with this liquid surface. Either both of this, it will be makes a exactly 45 degree, because this angle should be the 90 degree. And so what here we are considering that AC makes 45 degree exactly either of the surfaces. Then what about that? The AR with the net force acting on molecule A. Okay, what is that? Resultant force acting on molecule A. Okay, that is a vertical along the solid surface. Okay, as you observe that, where is the resultant force acting? Okay, now we observe here according to the law of parallelogram. Okay, I will just represent you where the resultant should be present. So let's just draw parallel to the AC. Okay, somewhat it is parallel, and again draw parallel to the AP like this. Okay, so AP be the parallel to this line drawn, and now this line should be parallel to AC. So the result of this should be the what? It is the along this line. Okay, as you observe, this is the resultant direction. So that can same got in the figure now. You can observe it. AR be the net force, and that resultant is given by here. Okay, you can observe what is the AR. AR should be along the surface. Okay, so in this manner, what we can say about the AR. Okay, again observe it carefully. AR should be along the surface. It is vertically downward along the solid surface. Then AT with a tangent drawn to the liquid surface. AT is the tangent drawn to the liquid surface, that is normal to AR. Okay, so as AT with the tangent drawn to the liquid surface, which is normal to AR and represented like this, perpendicular to the AR or tangent to the liquid surface. Okay, so in this case, theta with the angle of contact, and which should be given by, okay, the theta should be 90 degree here, that is the angle in between solid surface and the tangent drawn. Okay, so let's see here, you can see again in the figure carefully, you observe the angle drawn here. Okay, how it should be? It should be the 90 degree in between the solid surface and the tangent drawn. So the example of this, okay, which is actually not given in the book, but the example is pure water in a pure silver can form the angle of contact 90 degree. So in this case, the force acting okay, between the cohesive, means the relation between the cohesive force and adhesive force in this condition should be the AP is equals to AC divided by root 2. Means what you observe here, the force AP represents the AP represents adhesive force between the solid and liquid, and AC represents the cohesive force between the solid and liquid. Okay, so you can say here, this is relation gives us the force of attraction with cohesive force and adhesive force. Here AP is equals to AC by root 2. This can be also written as a, okay, you can write here instead of this simply, that is adhesive force is equal to cohesive force, okay, divided by root 2. So adhesive force is equals to cohesive force divided by root 2. It's a simple one, okay. So in similar manner, now we have to study the conditions for producing the concavity and convexity. So first condition is for first condition is for concavity. Okay, what is the concavity here? So that is simple, means formation, condition for formation of concave meniscus. So how the concave meniscus forms here? In figure you observe there, a concave meniscus is formed due to the water poured in a liquid. In this case, the meniscus should be concave, the angle formed is the acute angle, and important thing, relation between the AP and AC. So AP should be greater as compared to the AC by root 2. Okay, means the value AC by root 2 should be the smaller and AP should be greater. Okay, in terms of AP and AC means what? The force of cohesive force of attraction for cohesive and adhesive. So in that case, what you can say for formation of concave meniscus, the condition should be the adhesive force should be greater as compared to the cohesive force divided by root 2. Okay, you can see here clearly the equation. Then next is for condition for convexity. So in case of formation of convex meniscus, when there is a formation of convex meniscus, okay, the diagram should observe like this, and you can say that there is the formation of obtuse angle. The obtuse angle is formed there, and the condition between the cohesive and adhesive force is represented as AP should be less than AC divided by root 2. Okay, means what? The adhesive force should be the less as compared to the cohesive force by root 2. Adhesive force should be less as compared to the cohesive force by root 2. Okay, as you observe these relations, so what you can say here, you can see that this AC by root 2 and AP, everywhere it should be the same. Okay, only the difference is that for formation of plane meniscus, you should have, okay, the equal sign. For formation of concave meniscus, you should have the greater sign. Okay, and formation of convex meniscus, you must have the sign of less than. Okay, so in this manner, this is your topic, that is the angle of contact, formation of 90 degree. Okay, so the next point that we have to discuss in this lecture, that is shape of liquid drop on solid surface. Okay, means what? When a liquid drop pour on the surface of solid, which shape it will be formed? So that here we have to discuss. For that, we have given that when a small amount of liquid is dropped on a plain solid surface, the liquid will either spread on the surface or will form a droplet on the surface. Okay, means a simple question is there. When you pour the liquid on the surface of solid, okay, you should use the dropper and put the liquid on the any surface of solid. So at that time, what it result? Which shape it will result? Okay, it may result the spherical shape. It may will starts to flow over the surface of solid. Okay, means which kind of formation of shape takes place is should be depends on, okay, on which factor does it depends. So this will be occur, means which phenomenon will occur, that will depends on the surface tension of the liquid and the angle of contact between the liquid and solid surface. Okay, means what? There is a formation of spherical droplet, there is a formation of concave meniscus, convex meniscus, plane surface, whatever it may be. That all things are depends on the surface tension of the liquid and the angle of contact between the liquid and the solid surface. The surface tension between the liquid and air, as well as that between solid and air, will also have been taken into the consideration. Okay, means what? You observe here, in case, okay, we consider this diagram. From this diagram, I will explain this 2 lines. Okay, what is that? The surface tension between the liquid and air, as well as that between the solid and air. Okay, here we consider this is the solid on which this liquid drop is put up. Okay, so in that case, what we can say, this will be depends on surface tension between this solid as well as liquid and air also. Okay, liquid air also and air solid also. Okay, so on all this content or the surface tension between all these 3 parameters will decides the formation of liquid drop. Okay, so let here we consider that a solid surface on which we put a liquid drop, that will shown here by yellow arrow. Okay, now the medium about it should be the air, means all these 3 mediums are exist in this case, solid, liquid as well as air. Then we consider here T1 be the force due to the surface tension at the liquid solid interface. You observe the diagram carefully, in which you observe that solid and liquid surface are keep in a contact. So we consider that there is the surface tension between the solid and liquid, which shown here like this. Okay, so what is this? T1 be the force due to the surface tension at the solid liquid interface. Okay, means where the solid and liquid are in a contact, the force developed there, and that is called surface tension, and that is your T1. Similarly, what about the T2? T2 be the force due to the surface tension at the air and solid interface, where the air and solid are in a contact. There should be the second force will be generated, which is called T2, which is shown in the diagram. That T2 should be the force of attraction between the force due to the surface tension at air and solid interface. Then next is your force due to the surface tension at the air liquid interface. Air liquid both are get contact, where there is the formation of third force, that is T3, which shown here like this, which is a somewhat tangential to the liquid surface, and it is a surface tension between the liquid and air molecule. So here we consider that theta be the angle of contact for the given solid liquid pair. So how it can be drawn? By same way, by same definition. So this is the angle theta as shown in the figure. Okay, so theta is the angle in between the solid and liquid pair. Here we can see that, okay, the force due to the surface tension is tangential to the surfaces in contact. Okay, we consider here the forces T1, T2 and T3. Why these forces are produced or why these forces are taken into the consideration? Because of the forces considered here are tangential to the surface in contact. Okay, means these forces considered here are tangential at respective surfaces. You observe there T1, okay, is tangential to the liquid and solid interface. T2 is in air and solid are comes closest to each other, means where the air and solid are comes in the contact, okay, at that particular interface we draw the tangent, and so this sentence is there, the force due to the surface tension is tangential to the surfaces in contact. For equilibrium, means at the equilibrium condition, the forces acting on a given molecule should be like this: T2 is equals to T1 plus T3 cos theta. Okay, how it should be? So it's a very simple. As you want to calculate this T1, okay, so here you found that we have to be consider the projection of T3 on T1, means this is the another vector created here. Okay, so this T2 is along this direction, but T1 is directed along this direction, and another one, that is the projection of T3. Okay, and as per the diagram, or from this one, what we can say, as this is your angle theta, so you can say that this is nothing but what? That is the cos theta. So therefore, you can say it is not only T3, so it is what? T3 cos theta as a projection of T3 on a direction of T1. Okay. So let's see here, T2 is equals to T1 plus T3 cos theta. Okay. Understood? T2 is equals to T1 plus T3 cos theta. So therefore, we will write here T3 cos theta is equals to T2 minus T1. Therefore, what we can say, the cos theta is equals to T2 minus T1 divided by T3. Okay. So this diagram is given in your book, which looks like this. Okay, same diagram can achieve here, okay, by making the animated view. Okay. So we will get the formula for formation of meniscus, okay, or shape of the liquid drop. So what is that? Cos theta is equals to T2 minus T1 divided by T3. Okay, means here the angle of contact now decide. Okay, so you can observe here our formula is cos theta is equals to T2 minus T1 divided by T3. So now here case 1, related to that we have to consider the case number 1. If we have T2 should be greater than T1, as you observe here, okay, as you observe here, T2 should be greater than T1. So in that case, what we can say, this T2 minus T1 is also greater than T3. Means we consider the two conditions here. One is T2 is greater than T1 and other is T2 minus T1 should be less than T3. Means in short, this numerator is less as compared to this denominator. Okay, this is your T2 minus T1 and this is your T3. So T3 should be greater and this subtraction should be the less. In that case, what happens? So here you observe that there should be the angle cos theta and this cos theta becomes the positive. Okay, what is the cos theta which becomes positive? Because this number should be the less and this number should be the greater. Numerator is less, denominator is greater. As you make the division, so cos theta observes to be the less than 1 but positive, because T2 minus T1, in which T2 minus T1 is the positive. Okay, understood? Then the angle of contact form here, which is the acute, and forms the shape of meniscus as a convex meniscus. So what is that? Example is your kerosene in a glass. Okay, so look again what I am saying. Okay, for this case, T2 minus T1 should be the positive, and which is less than T3. Because of that, cos theta becomes positive and less than 1. So angle of contact should be the theta, which is the acute. Okay, because everyone know that, okay, the value of cos theta less than 1. Okay, and so the kerosene in a glass is the example of this case. In case 2, okay, what you observe, just somewhat different. T2 should be the greater, T2 is less and T1 should be the greater. Okay, but obvious, what is our formula? T2 minus T1. So therefore, T2 minus T1 should be the negative. Okay, the answer comes to the negative. Okay, and second thing, this numerator should be less as compared to T3 denominator. Okay, in this case also the value of numerator should be the less. Okay, and value of denominator should be the greater. So therefore, again what happens? Cos theta having a value negative and less than 1. Okay, so because of that, the angle form here should be the obtuse. Okay, as obtuse angle is there, means the shape form is what? Concave meniscus. And the example for that one is the mercury in a glass. Okay, so you can observe the formation of meniscus, and okay, the simple shape is there, and the angle theta also, which is the obtuse. Then case 3. What is the case 3? In which we say T2 minus T1. Okay, T2 minus T1 is equals to T3. Here T2 minus T1 is a positive, as well as T2 minus T1 is equals to T3. So in that case, what we can say, cos theta is equals to 1. Okay, and so which is the nearly equals to 0. Value of cos theta is 1 for a case 0 value of angle, and so theta is equals to 0. That is your case 3. Okay, so case 4, what is that? T2 minus T1 is greater than T3. Okay, now observe, out of these all cases, it's a different. What is given here? In the previous case 1, 2, what you observe? Numerator is smaller and denominator is greater. Here numerator is greater and denominator is smaller. Means the value comes to the greater than 1. The value of cos theta. Okay, as you observe here, in this case, okay, this numerator should be the, okay, numerator is greater than denominator. So the value always comes to the greater than 1. Okay, and the value comes to the, means value of cos theta should be the greater than 1. And everyone know that cos having a value between minus 1 to plus 1 through 0. Okay, means the value of cos theta lies in between minus 1 to plus 1 through 0. There is no value for cos theta greater than 1. And that's why what we say here, there is impossibility of formation of this case, where if occurs, the liquid spreads over the solid surface and drop will not be the form. So friends, in this manner, these are your different cases, okay, related to the formation of shape of liquid drop. Okay, so we'll stop here. If you have any doubt related to the lectures, okay, or related to these concepts, understanding, okay, so you can ask them into the contact section. Okay, so friends, thanks for watching video. Thank you.